So, welcome. This is the Puppet Camp on April 15th. I'm going to talk about Puppet code testing and especially comparing modules versus Control-Repo testing. And Nigel already introduced us and said we are more users than, there are more Puppet users than are Puppet developers. Where I have to say, Nigel, maybe I see it differently. Every Puppet user is a Puppet developer, just most Puppet users just don't know that they are Puppet developers, because there are people that do modules like the community things and put them on the forge. And on the other hand, you have people working in companies that want to automate their infrastructure using Puppet, so they work with a control repo. Both do the same, they write Puppet code. So from this perspective, maybe both are developers. Maybe the module developers have some other toolings compared to the people doing the control repo. And this is where I want to talk about specifically the toolings for testing Puppet code. So who am I? My name is Martin. I'm CEO and co-founder of Example 42. We do Puppet consulting, training, and individual development for several companies. You can find me as Tuxmia on Twitter, GitHub, and Slack. And so far, I'm using Puppet since, I suppose, the stone ages of Puppet, which makes me somehow one of the Puppet dinosaurs in this area. So today I mentioned I'm going to talk about Puppet code testing. And the first thing always comes up, why do I have to test my Puppet code? So what's wrong with it? I can just deploy it and test it in production. But maybe you don't want to have broken Puppet code in your Git repository. Maybe someone is already branching while you're still fixing. So you want to prevent that you get compile parser errors on your code. You want to maybe test if you can upgrade to a newer version of Puppet. I hope most people now consider moving on to Puppet 7 and step back on using Puppet 5 anymore. Maybe you want to test that you do some refactoring. You're switching from one upstream module to another module, and you want to see whether everything is working. You're adding into an upstream module new code that manages a new operating system. So you want to test everything prior you put stuff into production. Okay, so we now understand, okay, we can do testing. And then we dig around and look, what is it? What kind of tools are there that help us doing all the stuff? And it's quite funny that I almost have the same list as Nigel in his talk. So we have something like Puppetlint, like RSpec Puppet. We now heard about PDK, the Puppet Development Kit. Usually when having an audience, I'd like to ask how many people already have heard about Onceover or are even already using Onceover. Some people might have heard about Beaker, some know about Litmus, some heard about ServerSpec, and some have checked out and found that there is a Vox Populi website, that's the Puppet community on GitHub, and they have a list of plugins and extensions, a huge list of extensions, especially to Puppetlint and RSpec Puppet. As someone who's not used to do testing and wants to write Puppet code, I'm now asking myself, wait, I just want to write Puppet code. Now I must learn testing, this RSpec thingy and the Beaker and Litmus thing. What is it, how it is working? And I must do everything right in the first place? And the best thing to do is choose the most simple solution. So choose something that helps you doing testing with the least effort at all. Maybe we should first have a look on what is it that you want to test, because there are several different tests available and you can run them independently. The very first test you definitely want to have is the lint testing of Puppet code. You want to ensure that the Puppet code that you're developing follows the Puppet style guide. There's a web page on Puppet that describes on, I don't know how many pages if you print them, several, how code should look like. It's not about how code should work, it's about how should it look like. And there is a tool around Puppet lint that enables you to test whether the code that you are writing follows the style guide. The next step of test is some kind of unit testing. Within the Puppet ecosystem, this means that we somehow take the Puppet code, compile a catalog. I hope everybody is aware that a catalog is just a minified JSON object, and we just parse this catalog to check whether resources are inside. We check whether a catalog is created at all. And we check if certain resources like classes or file resources or user resources are inside the catalog. And last but least, we have the acceptance tests. That means that we really spin up temporarily a system. We deploy the Puppet code inside, we apply the Puppet code inside, and afterwards we analyze the system and check whether we have a service running, whether a firewall port is open, so that we really know that the code does the right thing on the systems. So, okay, we now have heard about tools. We've heard about why we should test. Let's start with testing, and first testing modules, really upstream modules. I prefer to call them library modules because compared to other programming languages, it's just an extension that you can simply install on your Puppet master, and then it's available for usage. The first question, of course, comes when people start doing testing: where should I run the tests? And some people prefer to have them on the workstations. Others say, no, let's put them into some kind of continuous integration pipeline. Usually I prefer, that's not an or situation, that's an and situation. You should be able to run tests on your workstation, whether that's a Windows system, a Mac OS system, a Linux system, that's out of scope. You should be able to run your tests within these platforms. And you should do something within a CI pipeline, especially when you make things public or collaborate with multiple people. Everybody wants to assure that the code is working properly, and everybody wants to be sure that he adds some new content to the Puppet code, that he's starting with green tests. For testing modules, Puppet has released PDK a couple of time ago. That's the Puppet Development Kit. The benefit of the Puppet Development Kit, especially from a user perspective, it's a single package that you have installed, that you have to install. There's an MSI package for Windows. There is a disk image for macOS. There's RPM or Debian packages for Debian-based and Linux-based distribution. So it's a single package. Take care, it's a huge package. It's a huge package because everything is bundled inside. So once you have PDK in your infrastructure, no further internet access is needed to do things with PDK. So you don't have to download additional Ruby extensions, testing frameworks. Everything is bundled inside PDK. And the nice thing with PDK is that it also bundles different versions of Puppet. So it allows you to run tests and to provide a version. For example, you are still running on Puppet 6 and you want to test whether your code is also working on Puppet 7, then you can just run PDK with an option like -- Puppet -version and just say, please test this with Puppet 7. So how do we use now PDK within the scope of modules? And please, library or component modules. This is not about roles and profiles. This is something I will cover a little bit later. PDK can be used to generate a complete new module structure. PDK is also capable of converting an existing module into PDK compatibility. And when you once have a PDK compatible module inside your module, you just can use the PDK new command to create new classes, define types, facts, functions, providers, tasks. There's a huge amount of stuff that creates stubs for everything, like empty classes, plus it automatically generates the spec testing files. When you've added your code, you just have to run two commands, PDK validate. The PDK validate does the syntax testing for you. So it checks whether the code that you have written follows the style guide, like indentations done properly, did you do the rocket alignment properly on a resource type. It even allows you to specify a parameter for automatic fixing your broken style guide code. And it allows you to run PDK test unit. And it will take your code, compile it into a catalog, and see that the catalog can be compiled. That's the minimal test that PDK provides for you. Maybe you have some dependencies, like on stdlib or inifile, or any kind of the Puppet 6 core modules, like the mount provider. This means that you have a dependency. Please add these dependency also to your metadata JSON and provide them into a .fixtures YAML. You can get the dependencies either directly from Puppet Forge, just take the latest version, or you can take them from the Git upstream repository, or if you're inside an organization developing a module specific for an application in your organization, you can also clone them, fork them on a local Git server and access them from there for testing purpose. You can also change the default behavior, how PDK generates a module at all. There is a PDK template GitHub repository. You can also provide your own PDK template Git repository in your infrastructure, because you're saying maybe you're not in need of a .travis YAML. Maybe you have other pipeline systems, but then you can add pipeline configuration directly into your own module template. When you want to adopt from upstream, you also have the possibility to add a .sync YAML and, for example, enable some Rubocorps, disable some Rubocorps, do something with a testing purpose. You want to adopt things. It means that you have to learn about the testing, but you have the possibility of adopting. If you have modified or created a sync YAML, please take care to run PDK update afterwards. That will take these changes into account and deploy them on your code base and the testing code base. When you do a PDK new or PDK new module, PDK will ask you several questions, like the name of the module, the author, and what is more important, which kind of operating systems does this module support? And this information is placed into a description file called metadata.json. So inside this file, you have an information automatically takes PDK the information from for which operating systems should I run tests against with the Puppet code. Yeah, but when I now consider you're not only doing modules, but you also have control repos and you have specific classes for specific operating systems, that sounds like a nightmare to adopt the test tool for Windows classes to be only tested against Windows version, AIX classes only to get tested against AIX. So let's have a look on how to continue with testing of control repositories. And first look, is PDK a solution that is capable of testing control repositories? Why do we start with testing PDK? We're using PDK for testing control repositories because, once more, PDK is simple to install. It's a single thing only, and it does most of the thing that people who are fresh with the code base need to know. The first thing, if you're using the roles and profiles pattern, then you have two modules in your control repository, a role module and a profile module. And these both modules must either be generated or converted to be used within PDK. Within your control repository, I assume that's the best practice standard. It's just a definition that within the site directory, you have your profile module, your role module. So you just switch in that directory, you run the PDK validate command, and you're popping back into where you came from. I don't like CDing. That's the reason why I use pushd and popd. And you see, I'm more used to shell than to PowerShell thingies. When it comes to unit testing, you will learn that you have a huge set of dependencies, whether that's the Puppet Labs Apache module or Puppet Labs NTP module or a camp-to-camp postfix module or the example 42 network module. You will have a huge amount of dependencies. These dependencies are usually mentioned in your control repository's Puppet file. And now I have to maintain the same set of modules somehow in a, what was it, .fixtures YAML file, where I tell my RSpec tests what are the dependencies that must be installed. Oh my God, this sounds a little bit weird. We have a solution for that. Let's move on. What else is it that we want to do different when we do testing of control repositories? Maybe you want to use your own Hira config, the one from your control repository. Maybe you have changes done to your manifest site PPE. For example, every exec resource type automatically sets a path parameter. So you have some resource default built in there, which must be there so that Puppet won't complain about bad practices within your profiles, for example. So first of all, profile and role file must be in PDK format. When you already have existing modules not done with PDK, you can use PDK convert to convert the existing modules into PDK modules. And the second thing, you must have all the modules from your Puppet file installed locally. So you need R10K on the system, and so that you can run R10K Puppet file install. This will install the modules from your Puppet file locally on your workstation or on your CI pipeline system. Dependencies are placed into a fixtures YAML in your profile module or in your role module. Both modules also need some changes to the way how you test your code. I will provide some examples of this. First, we see the fixtures YAML. On the left-hand side, you see a fixtures YAML from the profile module. And there you see we are only doing symlinks. We're symlinking the profile. We are in the profile module, so we're just symlinking the source here. And then we generate another directory structure, not next to profile, but underneath to profile. And we just call this R10K, and we're symlinking our control repositories modules directory into the fixtures directory. We do the same on the role side. Just we are in the role module, so we have the source here, and the profile module is just located one directory underneath, and it's called profile and not role. And we do the same with this R10K based modules. Within your spec helper, this file is identically to both the role and the profile class. You tell RSpec to please use a different module path, not just the default one. We tell them to use the fixtures path modules and the R10K path, which is also in the fixtures path. We tell RSpec to not use the manifest year inside the fixtures path, but use the manifest year, which is located in your control repository. And as manifest, please use my site pp, and as Hira config, please use my Hira YAML in my control repository. Having these configurations added, we have the possibility to just run our control repository tests. So we run R10K Puppet file install, we go into the site profile, we run PDK test unit, we go into site role and run PDK test unit. When it comes to acceptance testing, we can also use PDK, but please be aware, Beaker and Litmus are part of the PDK, but not officially supported. It's some kind of experimental pattern. So you can run them directly with a PDK command, but PDK has the capability of running additional commands via a bundler command. If you want to find out which rake tasks are available, just create a module and run PDK bundle exec rake -T. It will show you which rake tasks are available, and there you will find the acceptance testing rake tasks for both Beaker and Litmus. Wait, one step back. The unit testing. How do I deal with roles or profile classes which are designed for a specific operating system? I have a class that is only used on Windows. I have been honest, and in my profile, I have specified I have several operating systems to support. I have some kind of Debian-based, Ubuntu-based, Red Hat-based operating systems, and Windows. So normally, PDK takes the class and tests them against all of these supported operating systems. One approach is adopt the spec tests for these specific classes to omit the operating systems which the class is not good for. So a class that is meant to deploy an MS SQL server and configure your Windows system, then you will say, don't test it on a Linux system, use this test only on a Windows system. And that again means lots of Hazel, lots of adoptions that are needed, and you will definitely learn a lot of stuff about RSpec and RSpec Puppet. But isn't there maybe a more simple way compared to modifying things which are generated? Can't we deliver things upfront in the right way for a control repository? And this brings us to another tool. It's called Onceover. Don't ask me why Dylan decided for the name Onceover. That's something that you can ask Dylan Radcliffe by yourself. Dylan developed a tool that is specifically created to test Puppet control repositories. So it is like a separation of concerns because library modules have other requirements on tests compared to your own infrastructure control repository things. Onceover is able to run syntax test, unit test, acceptance test, and even With a slight extension, one more thing, I'm going to explain that later. Onceover itself is provided as a Ruby gem, like most of the things that we do with Puppet. So if you just use a gem install and you just install Onceover, or you have a gem file in your control repository and you say these are the gems to install, you're just installing Onceover. Afterwards, you run Onceover init, and what you can immediately do is, once you have the Onceover code quality gem added, you can immediately run Onceover run code quality. And Onceover run code quality will then check the content of your Puppet file. It will run a rake task for Puppet syntax. It will check YAML validation, but it's using Python for that. And it will lint in the manifest directory. It will do the lint test in the site directory. It will do the lint test in your whatever directory structure you have else underneath. Now it comes to the unit testing within Onceover. And Onceover allows you, within a configuration file, which is in the spec directory and has the name onceover.yaml, that you can first add classes and specify which classes is it that I want Onceover to test. Then you can specify nodes. Let's say it's like operating systems. You can even use individual node names over here. It's just a group of a list of names. Usually it's operating systems, and you provide facts for these operating systems. You can also, on your existing platform, head over to a node, run factor, and take the output and place it into one of the spec directories in your Onceover directory. The documentation is really great. It explains it easily how you can expand it. The next thing is that you create class groups. So you put together, for example, these are Windows classes, and these are Linux classes, and these are AIX classes. So you can group them together in class groups. You can do the same with your node groups. You can group them together like test nodes, Windows nodes, Linux nodes, AIX nodes. The test itself is something you have to create by yourself. There is a default inside once you run Onceover init, but you have to adopt it. That's the reason why I explain people not directly start with Onceover. Start with PDK, because there you get the tests automatically added, and you can then take your time on learning RSpec. When you do Onceover, you should have experience on how to write RSpec, Puppet-based classes. A super short example for the spec Onceover YAML, we have one class inside, it's called role base. We want to test it against the CentOS 7 system. We just have a simple class group, it's named all classes. We have a simple node group, it's called test node, and we have a test matrix and have some specific notification here, it's called all nodes. And we say all nodes that we have in our system should take care on the class role base and run the spec tests inside. Once we have that file, we can just run Onceover run spec. And as you can see, Onceover will deploy everything into a .onceover directory directly in your control repository. And afterwards, it will just compile the catalogs using RSpec Puppet and compare the catalogs to what you have written into your spec tests. Acceptance tests are similar to PDK. They are located in spec acceptance. Please be assured this is somehow server spec that you put inside. It's unrelated to Puppet. It lets you test a finalized system, and whether the system has been configured manually or automatically, it's not within the scope of server spec. Node sets are something that you configure also. You want to have a couple of node sets, like several instances. You want to have a node for CentOS 7 and CentOS 8. You want to have a node for Ubuntu 20 and Debian 10. This is something you provide in your Onceover nodes YAML. A short hint, Onceover uses Beaker only at the moment. And Beaker there's been some discussion within Puppet Labs on how to continue with Beaker, and Puppet Labs decided to stop working on Beaker and do Litmus instead. Beaker is now handed over to the Vox Populi community, and basically lots of the stuffs are done by Trevor Vaughan from Onyx Point, but it's still under active maintenance. So maybe I'm going to write Dylan that this complaint no longer is needed because Beaker is under development, or maybe even moving to Litmus. I said with Onceover, you can run syntax tests, unit tests, and acceptance tests, and one more thing. When we've been at the customer, we were heavily needing something comparing catalogs, and we were dealing with octo-catalog diff and connected to a Puppet master. And now I learned there's a once-over extension. It's called once-over catalog diff. And you can just run once-over run diff, and you say, this is the from branch, and this is the to branch. So you have a feature branch, the from branch, you have a target branch, your production or master branch or main branch. And then you get just it compares the catalogs for the different operating systems. If you do a refactoring, you definitely would not like to see any changes running when you run once over run diff. Putting things together. First of all, everybody who does Puppet code is a Puppet developer. Most people who do the things still see themselves as users, but especially within the trainings, I congratulate every system administrator who attends a Puppet training. Congratulations on your new job. You're now an infrastructure developer because you're doing Puppet code. And when you are a developer, you want to do testing. Testing is important. For some people, it means a huge learning curve. Others might say, oh, it's easy to do. Especially the syntax and unit tests are super essential and super easy to do. For most people, the acceptance tests are a little bit harder. For example, Litmus says we have prepared Docker containers that run systemd, and several organizations we are working with, they forbid internet access. So everything must be built locally. So the biggest problem is properly building an instance to test against. Generally, follow the KISS principle. Keep it silly simple. So start with something simple like PDK. Learn about RSpec. When you have learned RSpec is no longer hard and it's simple. Maybe you can then move on to Onceover for Control-Repo testing. Once you have that in place, you might consider an infrastructure where you can do acceptance testing. PDK is the fastest approach that you can start with. It takes OS information from a module's metadata JSON, and when you now have control repos, it's hard to adopt it. Onceover has the benefit of it lets you build a test matrix regarding classes and operating systems to test it. Acceptance testings need some kind of infrastructure. Whether that's a cloud infrastructure or a local infrastructure is regardless. Both tools, Beaker and Litmus, provide capabilities to run on several different platforms. Within Beaker, there is the documentation available, what kind of hypervisors are available to be managed by Beaker. Litmus works a little bit different. They have a Puppet, they have an extension, it's called Provision, and that takes care on how to provision systems and afterwards run tests against. Last but least, please, we're living in difficult times, and everybody likes a lovely neighborhood, a livingly neighborhood. At the moment, we have huge, especially small businesses, have huge problems in this pandemic. Please take care to support your small, local, nearby, owner, or even family-run businesses. And everybody, please stay healthy and take care. And with that, I'm good to get questions.
Thank you for that last point, Martin. That is really thoughtful. We have a question from Chad. It was a little bit about Beaker. Could you talk about how Onceover uses Beaker and whether that's a required link or how they interact? I also see that Dylan hopped into the chat, so he can probably clarify later on too.
Please ask Dylan. I want to start first. He may complain afterwards about me being wrong. So Onceover has no dependency on Beaker. So you can install Onceover without using Beaker. Beaker is a separate extension that you can use afterwards. But once Beaker is installed, Onceover knows about Beaker and uses Beaker to run acceptance tests. It also, I suppose, it also depends on the configuration of your acceptance test, so what kind of backend you are using.
Cool. And Dylan also added the point that he started working on Litmus integration and hasn't had a chance to finish that yet. So our new developer experience team is going to be taking some of that on and getting Litmus better integrated into Onceover. So very shortly, you'll be able to actually use Litmus with Onceover. We have one more question here, and this was also the question that I had while I was listening to your talk. And Christopher Hughes wants to know what you do to handle like different kinds of facts, like different variants for different operating systems or versions or whatnot in your catalog. That PDK uses FactorDB to like populate some, but could you explain a little bit about how that works?
Okay, there is a factor DB, and within what you have in the metadata JSON, you say which kind of operating systems do you want to support with your module. This is read by PDK. PDK then looks within factor DB, do I have facts for that operating system and version there, and uses them. But sometimes these facts are not sufficient because you might have some external or custom facts which are not generically available on any operating system. With PDK, you can have an additional file in the spec directory, which is called default module facts. And there you can say, you can put in additional facts that are needed to run the tests properly. Within Onceover, you can provide facts on a per node system where you want to run tests against, or a per operating system. So it offers more flexibility for saying, I have one node that has a fact set to a certain value and another node that has the same fact set to a different value. This is the benefit of Onceover for control repositories that allows you to say set specific facts on specific nodes, where within PDK, I only found the solution to add facts generically to all classes test into the default module facts YAML file.
Cool. So sounds like what you're saying is like if you have facts for your module that then your module ends up using to make decisions, then you would use that no default facts file to put those facts in while you're testing.
Module default facts file, yes. Yeah. Mm-hmm. Yeah.
All right.
But you can't make them different for different operating systems. They are just generically set once.
Okay. Okay, we have one more question here. Could you please explain a bit more about testing modules Control-Repo targeting Windows nodes from the nodes running non-Windows nodes? And I think if I'm parsing this right, it's about like the complexities of testing different operating systems from like one operating system being the host and another operating system being the target that you're running the test against.
Yeah, you have that specifically when you, for example, run pipelines on Linux systems or on Linux-based systems, and you have code that is meant to be run on a Windows system. No, let's stay with a module and not with a direct control repository. The first thing is you provide the information about which Windows operating systems are supported. These must be added to metadata JSON. With FactorDB, the compiler pulls the fact from the FactorDB, like say for Windows Server 2016, and adds them. It adds them. So doing on a module perspective, it should just be enough to have facts available for that specific operating system. But that means that these information must be in FactorDB. I haven't found a way to add FactorDB outside the scope of FactorDB. So put something into your module which expands the knowledge of FactorDB about new operating system. I usually only found it possible to add it directly into FactorDB. But as long as you have your metadata JSON and you say this is a Windows-based operating system, you should, of course, take care on specific stuff like which provider to use. You should take care that there is a fact in FactorDB that takes care which package provider to use. Maybe you want to, if you set it explicitly in your code, then of course you just have to have the dependency like a Choco provider if you want to test installations, if you want to mock the installations in your catalog using Choco.
Well, and I wanted to make one small point to that is that the PDK and RSpec Puppet actually have some functionality within them that kind of mock out parts of the Windows subsystem. So that will help the spec tests actually pretend that it's on a Windows system to compile the parts of the catalogs that need that.